As promised, the second video for this lesson deals with continuity. Now, what does it mean to be continuous? Intuitively, we know what it means to be continuous. It means I can draw the function without picking up my pencil. I can draw the function without picking up my pencil. If I have a hole in the function, then to draw the function, I have to pick up my pencil. And so we would say that the green function here is not continuous at that point, right, at that x value right there. And we would say that the blue function is continuous across its domain and the red function is continuous across its domain. So let's formalize that. What makes a function continuous? Well, a function is continuous at some interior point C of its domain if the limit as x approaches C of f of x is equal to f of C. What does that mean? It means that there has to be a limit. The limit has to exist. The limit from the left and the limit from the right have to be the same. It means that the function value has to exist and they match. They match. There are two key ways that functions can be discontinuous in our course. I will demonstrate both of them. Neither will be earth-shattering. There's this kind of discontinuity. This is called a jump discontinuity. What goes wrong here? There's a function value, but the limit as x approaches C doesn't exist. The limit from the left and the limit from the right are not the same. Then there's this kind of discontinuity. This is sometimes called an infinite discontinuity. What goes wrong here? Well, the limit doesn't really exist. We would say that the limit is infinity. Infinity is not a number. And if it's not, infinity is not a number, it certainly can't be the function value at C. And so this is called an infinite discontinuity because the limit doesn't exist and it certainly doesn't match the function value, even if you want to treat infinity as if it were a number. So why do we care about functions that are continuous? Well, if f and g are both continuous at a particular value, then so are their sum, their difference, their product, their quotient if g of c is not 0, some constant multiple, some vertical stretch of f, f raised to a power, f taking some root. We can combine continuous functions and get continuous functions. And as a particular note, what does this mean? It means that every polynomial is continuous, and we study lots of them. Every polynomial is continuous, and that matters. That's an important thing. Why? This is why. This is the intermediate value theorem. And the intermediate value theorem says if f is a continuous function on some closed interval AB, and if k is any value between f of a and f of b, then k equals f of c for some c on the closed interval from a to b. Why does this matter? Why? Well, let's demonstrate what we mean first and foremost. You've got some function f of x, and you've got some closed interval a, b. Maybe it's a polynomial, maybe it's not. It doesn't really matter. And f of a, this is f of a, right? And f of b, this is f of b, right? If k is any value between f of a and f of b, any value at all, I just picked this one at random, there has to be a c between a and b where k is f of c. That's all that means. If I pick any value between f of a and f of b, and I draw the line to the right, it has to hit the red function somewhere between a and b. It has to. Has to. You're like, when would I ever use this? Well, your calculator does all the time. Here's example 2. We'll show that this cubic function, f of x equals x cubed minus 6x squared plus 4x plus 5, has at least one zero between -2 and 6. And the thing that I'll note about this right off the bat is that that's a polynomial. Polynomials are continuous. So the intermediate value theorem applies. What's special about this interval? Well, f of -2, if you were to plug -2 into that function, you would get -8 minus 24 minus 8 plus 5. I have no idea what that number is, but it's less than 0. And f of 6, well, f of 6 is 216 minus 216 plus 24 plus 5. I have no idea what that number is, but it's greater than 0. Well, what does that mean? That means that f of -2 is down here and f of +6 is up here. What are we trying to show? We're trying to show that that function f has at least one zero, one place where it has to cross this red line. So we're drawing a function that tries really hard not to cross the red line. It's trying really hard not to cross the red line. It's trying not to cross the red line, except that it's got to get to here. And it's got to be continuous, so it can't break. And so it's got to cross the red line somewhere between -2 and 6. Your calculator does this all the time. When you ask your calculator to find a 0, you bring the little spider to somewhere where the function is negative, and then you bring the little spider to somewhere where the function is positive, and what does it do? It finds the 0. Why? Because the intermediate value theorem applies, and your calculator assumes that your function is continuous, so it has a way to find that 0. By the IVT, f of x has a 0 on -2 to 6. I hope that makes some sort of sense. And if not, I hope you'll ask about it when we gather. We'll see you in class.